Hello all, my name is Pradeep Chaman and today we are going to see what is a standard deviation, then what is a Z score. If I got standard deviation, why we requiring Z score? Then in standard deviation you always remember as a part of denominator we are having the n minus 1. So why n minus 1 is considered, why always we are subtracting 1 from the number of reading, that is n minus 1, that we are going to see. So let us start with the standard deviation. So before starting, I would like to tell the variance. Before starting the standard deviation, I would like to tell the variance. So what is the variance? That is the average of square difference from the mean. So to understand the same better way, I have taken one example. There is a class in which there are students from, I have taken the 5 student, I have taken the 5 sample, and I have taken asked them what are the average mark they have got. So I got a mark from 5 students, that is the first one is a 85, 95, 75, 80 and 90. So very easily I can calculate the mean, how it is calculated. All these reading are added together divided by number of reading, that is a 5. That mean I got 85. So in the graphical way it is also represented. For example, 85 first student mark is mark over here, then 95 second, then 75 third one, 80 and 90. So I wanted to calculate the variance. Now from the definition we seen that it is a square difference. So how to calculate the square difference from the mean? So now I got a 85. So that will be from, rather from that mark, mean will be subtracted. 85 minus 85, that will be 0. 95 minus 85, that is a mean, that will be 10. 75 minus 85, that will be minus 10. 80 minus 85, that will be minus 5, and 90 minus 85, that will be plus 5. So here you can see I am getting difference for the few number plus and few number minus. So that's why I need to square it. So to get the read of minus sign. So if I square each this difference, then I will be getting number like 0, then 100, 100, 25, 25. So it is an average of square difference from the mean. So I got the square difference from the mean. Now I need to calculate the average. So how average can be calculated? So I will be adding all these square difference together, that will be 250 divided by 4. Now number of reading are 5. Now instead of 5 I am taking the 4. Why? Because I am subtracting 1 from the number of reading. Why? That also we are going to see. And if you calculate this, 250 divided by 4, that will be 62.4. Now for the variance, which formula I use? Same formula, that is a statement, that is the average of square difference from the mean. So here you can see individual reading, from that average is subtracted and square is made, divided by n minus 1. So same thing what we did, that is written in the form of formula. So that is a formula for the variance. Now coming to standard deviation, it is simply square root of variance. So whatever we have seen, we have to take the square root of that number, that will be standard deviation. So it is extract from previous slide. We have got variance 62.4, and standard deviation is equal to square root of variance, and if you take the square root of 62.4, that will be 7.9. So that is a standard deviation. And the formula in the previous slide we have already seen. So this was a variance, so I have to take the square root for this thing, so that will give me standard deviation. So if I tell this formula directly, you would have not get clarity. So if I take the example, then clarity will be there. So that's why I have taken the example. Okay, now coming to interpretation of standard deviation. Now these are the mark which I got for the 5 student. Now this is the mean. Now standard deviation 7.9, so it can go up, it can go down. Are you getting me? So this is the significance of standard deviation. It is a average difference from the mean of each student or each sample. So it is a average difference from the mean. Are you getting me? That is a standard deviation. Now let us talk about the Z score. Now data were taken, and for that same we wanted to calculate the Z score. This is a formula. Data point minus mean value divided by standard deviation, that is a Z equal to x minus x bar divided by s, and this is for the population, because population sigma is standard deviation for the samples, s is always used as a symbol, and for the mean, that mu is used for the population case, and for the average x bar for the sample case. Now in the Z score you have to consider mean as a 0, so Z equal to 0, and left side and right side how it will be going. So you have to take the how many number of standard deviation are there, that is a 1, 2 and 3. So here one standard deviation, two times standard deviation, three times standard deviation. Why? Because you have to consider mean as a 0 and standard deviation as a 1. So same thing is applied for the right side also. Are you getting me? So in previous slide we have seen standard deviation is 7.9. Now standard deviation 7.9 is considered as a 1, and mean 85 is considered as a 0, and you have to describe the distribution how many standard deviation is lying left side and how many standard deviation is lying right side. So 1, 2, 3, and corresponding the actual value of that particular x or the data point will be x minus 1 sigma. So 1 sigma is a 7.9. So corresponding value for the 1z is 77.9. How it has got 85 minus 7.9, then 2 sigma, that is a 69.2, and for the 3 sigma, that is 767, sorry, 61.3, and corresponding z will be 3. Are you getting me? And similarly right side same thing is applied. So why it is required z score? Standard deviation, of course, it is a ruler for the measurement unit, but for the standard deviation, there is a unit. So, whatever unit you have got for the sample, same is for the standard deviation, for example, minutes, kilogram, millimeter. So, how to get rid of the unit of the standard deviation so that I can compare two lot? So, there will be standardization. So, that's why Z score has come into the picture. So, Z score ignore the measurement unit, for example inches, hours, score, etc., and it is calculated by considering the mean as 0 and standard deviation as a 1. So what we are exactly doing, we measure the distance from the mean by the number of standard deviation away. So how many number of standard deviation away from the mean? So same example we have seen. Okay. Now let us come back to our standard deviation formula, where in the denominator we are dividing n minus 1. Why we are subtracting 1 from the n? That is the question. Okay. Now see, there is a population. From the population you are taking the sample and you are drawing the conclusion about the population. Ideally, when you are taking the number of sample in the population case, it will be same as quantity or number of thing, but it will be reduced by 1 in the sample. Why? It is for the adjustment. What is the meaning of this? Let us see in the next slide. Now see, this is a green graph for the population, and in the population, whatever cross are made, these are the sample or the jobs lying in the population. Now in the population, you are taking particular, sorry, particular job in a such way that you are predicting the population. Now this is a sample. So whatever yellow or the orange graph we can see is a sample graph. Now at the initial stages when sample are less, it is looking like this. But when you are increasing sample, it will be almost matching with a population graph. And when number of sample equal to number of population sample or the quantity, it will be fitting to the population graph. I mean to say this both graph will be same. But in the sampling case, when you are taking less sample, so when you are taking sample from middle, sample from left side, sample from the right side, then standard deviation will be okay, that will be same as the population standard deviation. But we don't know practically from where we are taking the sample. So most of the sample are taking from the left or the right at the particular skewed point. What I mean to say, if I take the sample from this area, so red kind of thing cross are shown. So if sample is taken from this, then if I draw or the conclude the sample standard deviation, it will be always less compared to population sample deviation. So whenever I am having the initially less sample, then I have to adjust standard deviation by reducing denominator. By reducing denominator means some this particular fraction will be increased. So I want to increase standard deviation at the initial stage. I have to subtract denominator by one number so that at initial stage that will be, you know, increase standard deviation. And when as I will be increase the number of sample, it will be, standard deviation will be matching. So that particular fraction will be equivalent to population standard deviation. What I mean to say. So now let us go to the next slide. Now it was experiment was done, and how to reduce the denominator so that the fraction, what I mean to sample, you know standard deviation, rather here we will take the variance. Standard deviation is developed rather calculated from the variance, that is a root mean square. So let us take variance for the easy understanding. Now we are having the same case, that is the number of job from the one class, that are the 5 and each having this value, and variance is 62.4. Now this 250 will be remain same. For the comparison purpose we will keep this same. We will talk only about the denominator. Now it was proved that if I reduce the denominator by subtracting, 1 from n, then my standard deviation or the variance in this particular case will be almost matching to the population variance or the n, not population variance. It is almost matching to the n if I'm not subtracting that thing. Now here you can see number of sample, I'm sorry, number of sample 5. Now we will take only denominator, 250 will remain constant. So after calculation we will having this particular figure, that 250, that is 62.5, that is 250 divided by n minus 1, and here in this column it is divided by n. Now after division of n, this is the figure, and after division of n minus 1, this is the figure. Difference you can see, it is almost matching when number of sample size is increased. Are you getting me? Now that's why n minus 1 is taken. Now initially experiment was done, sample are taken from middle, from right, extreme right, from the extreme left. Then question may be asked, why not to increase, instead of n minus 1, why not to go for the n minus 2 or n minus 3? Answer is here. If you take the n minus 1, then here difference between this n and n minus 2 is not matching here. Are you getting me? So perfect thing what I is there, that is n minus 1. That is the reason why that n minus 1 is considered as a denominator for the variance. Of course it is carried forwarded for the standard deviation also. So second deviation definition or the criteria for n minus 1 is given in the book, that is a degree of freedom. Now see, when you are having the one particular length, let us take one particular case that we are having the 30 millimeter length of the rod. Now you want to divide into 3 part. So initial 2 part you have got a choice, you can divide. Are you getting me? But third one you cannot divide, rather decide. So 3 is a number of sample and 2 are the thing where you have got the choice. For the third one you don't have choice. So here they are saying x3, x1, x2. So you can decide x1, you can decide x2, but for the x3 you don't have a choice. So same example of the rod, 30 mm, I want to divide into 3 pieces. So I can take first piece 5, second piece 5. Of course I can take any number. So I got 2 pieces, that is a 10. What is remained, that third one is only 20. For the 20 I don't have choice. So we don't need to know all 3 data point when estimating the sample variance. So x3 where we don't have choice, that is why we need to have degree of freedom, that's why we divide, that is n minus 1. So this is the second reason. So these are the 2 reasons because of which that the standard deviation is divided, rather variance is divided by n minus 1. So that's all from my side. Thank you very much for joining this session. Thank you.